Alright, here we go. Is everybody ready? So, moving right along with Unit 8, we have our next objective or our next set of notes. And it is explaining Newton's second law. Okay, so yesterday we learned about Newton's first law. And that's the one that says an object at rest will stay at rest, or an object in motion will stay in motion unless acted upon by an outside force. Okay, so that's his first law. His second law says that the unbalanced net force on an object will cause acceleration. Okay? The unbalanced net force on an object will cause acceleration. And then it tells you kind of how these things are related. Okay? How force and acceleration are related. The greater the force, the greater the acceleration. Okay, so if we have a really big force, we're going to have a really big acceleration. Okay, if we have a really big mass, we're going to have a small acceleration. Alright, our new formula for Unit 8 is F equals ma. Okay, so F is going to be force. We've been talking about forces this whole time. Forces are measured in newtons, a capital N. And then ma, they're beside each other, so what kind of calculation would we do with those?
Multiply.
We're going to multiply mass times acceleration, and that gives you force. Okay, our mass is going to be measured in kilograms most of the time. And then we've talked about acceleration in Unit 7 with velocity and all of that. And we know that that unit is squared, meters per second squared. Okay, that part should not be new to you. We learned about acceleration in our previous unit. Okay, and then we have another triangle. Okay, I like the triangles. It makes you have to think less, which I bet we're all happy about, you know. And it works the same way. So if you're looking for acceleration, you cover it up, so you're going to do F divided by M, right? If you're looking for force, you cover that up. These are beside each other, so we multiply. Okay, and so on like that. The triangle shouldn't be new to you either. It's just new letters. Okay? So what we got to do is use this triangle and find whatever missing variable the problem gives us. Sound like a plan? All right, so let's go ahead and do some of these examples. Like I said, we're not going to do all of them. Because there's a ton on here, but we are going to do some of them for sure. All right, example 1. There we go. What is the acceleration of a 225 kilogram object that has 225 newtons of force? Okay, so first things first, we are going to determine what variables we have. All right. Where would you put 225 kilograms? Is that F, M, or A? That's M. Okay? So 225 kilograms. And what about 225 newtons?
That's force.
That's force. Big N is force. Okay? So we have 225 newtons of force. So I am looking for A. That's my missing variable. Okay? If I put my triangle up here, I'm looking for A. What am I going to do with F and M? Divide. Which one's going to go on top? F. Okay? So F is 225 newtons. Divided by mass, which is also 225. What's 225 divided by 225? 1. Okay, so I'm going to have an acceleration of 1 meter per second squared. Okay, because we remember acceleration is measured in meters per second squared. Okay? How's this going for us so far?
Good.
Good. Good. I hope so. All right, let's move on to the next one. An object experiences 10.2 meters per second squared acceleration when pushed with 114 newtons of force. Find the object's mass. Okay? So what variable is 10.2?
It's acceleration.
That is our acceleration. So 10.2 meters per second squared is acceleration. What about 114 newtons?
Force.
Force, okay? Newtons is always going to be force. So I have 114 newtons there. I got to find a good marker. All right, so that tells us that I am looking for mass. If I think back to my triangle, I'm looking for mass, so that's what I cover up. What do I do with F and A? Divide. Okay, F on top. So 114 newtons divided by 10.2 meters per second squared. $11.2 maybe?
11.1.
Point
Yeah, it's
one?
11.2.
Okay.
If you're right.
So I divided those in my calculator. 114 divided by 10.2, you get 11.2. And I'm looking for mass, and mass is kilograms. So my unit would be kg for mass. Everybody comfortable with that? Okay, we're going to skip that third example down there and turn the page. And we're going to do the same triangle. We're just going to include it with free body diagrams. Okay? I am more than 6 feet away from y'all, so my mask is off. Sorry. Okay, so we're still using F equals MA, but now we're going to look at free body diagrams with this equation. Okay, kind of tie what we've been learning with what we're learning today. So, okay, that's good enough. Draw a free body diagram showing all forces. Find the net force and the acceleration if the object has a mass of 10 kilograms. Okay, so just from that, I know that I have a mass of 10 kilograms. So that's going to be my M, 10 kg. And then it says gravitational force is 98 newtons. Okay, so this is where we're going to draw our free body diagram. I'm going to start with my dot in the middle. Okay, there's my dot in the middle. Gravitational force. Which way is that arrow going to point? Down. Gravity points down. All right, so I have an arrow pointing down, and that one is 98 newtons. Applied force is 100 newtons to the right, so that one tells us which way that arrow is going. So to the right, I have 100 newtons. And 10 newtons of kinetic friction. The normal force is 98 newtons. Okay, so which direction would the friction force go? Left. Okay, so I have a left arrow of 10 newtons. And normal force is 98, and that's going to go up. Normal force typically is what opposes gravity. Okay, so it goes opposite of gravity, and that one is 98 newtons. So I already have my mass, okay, of 10 kilograms. From this free body diagram, am I able to get net force or acceleration? Net force, okay? We've done this, all right? So if I'm calculating net force, opposite arrows subtract. So my up arrow and down arrow cancel out. Do y'all see that? Okay, they're both 98, so they cancel each other out. I'm going right at 100 newtons and left at 10 newtons. So what's the difference in that? 90. So 90 is my net force. 90 is going to be part of my problem. Okay? So that means I'm looking for acceleration. Does anybody remember off the top of their head how we find A? What do we do when we have F and M?
Divide.
We divide, okay? You can always go back to that triangle if you need to. F, M, A. All right? So in order to find acceleration, we are going to do F divided by M, which is 90 divided by 10 equals 9. Y'all are geniuses, I swear. And what's my unit for acceleration?
Meters per second.
Squared. Yes, meters per second squared. Okay, so now we are tying in everything that we've learned so far. Okay, this is the new stuff. This is the old stuff. It all fits together. Y'all see that? All right, we're going to do just 2 more examples of our free body diagrams because I think it gets a little bit repetitive if we do all of the examples. If y'all want me to do more examples, just let me know and I will, okay? If we need a little bit more of an understanding. All right, looking at this next one. Draw a free body diagram showing all forces, find the net force, blah, blah, blah. In free fall, if the gravitational force is 108 newtons, all right, so here's my dot. Gravitational force is 108 newtons. Did y'all say 108 or 98?
98.
Sorry, y'all says 98. My bad. That was my fault. 98 newtons. Air resistance is 10 newtons. Which way would that point? It's going to point up. So if this is something is in free fall, whenever it's falling, air resistance is going to push up. So we have an up arrow of air resistance, which is 10 newtons. And the mass of the object is 10 kilograms. So that tells us the mass right there, 10 kilograms. What else can I get from this situation? I'm going to subtract them. 98 minus 10. 88. Is that force or acceleration? Force. Okay, so we have 88 newtons of force. Once again, I am looking for A. We know if we look at our triangle that I'm going to do F divided by M. Mia found them. Okay, so I'm going to do 88 divided by 10. Anybody know that one?
8.8.
Tried to sneak one by and all didn't work. Okay, so we get 8.8, and it is acceleration, so meters per second squared. Everybody good with that? All right, our next example, go ahead and turn your paper over. It's example 5. We're going to skip ahead and go straight to example 5. And that one gives us a free body diagram. We don't have to draw it. It just says, find the acceleration and direction of this object. The mass is 15.6 kilograms. So that tells us right off the bat that we have 15.6 here. Okay, looking at this free body diagram, somebody tell me my net force.
It is 450.
450, that's correct. So these 100s will cancel out. I have to do 500 minus 50. So my net force is 450 newtons. Before we do any calculations, let's talk about direction. Which direction, you can tell from this free body diagram, is this thing moving? Left, right? Because this 500 is going to overpower the 50, right? So this whole thing is going to be moving left. So we already figured out direction. Great job. Now, looking for A again. What do I do to find A? I'm going to divide. Okay, so A equals F divided by M. 450 divided by 15.6. Do that one in your head.
Y'all made this hard.
Hard?
It's really not.
How is it hard?
Oh, I thought like you do like easy math and you don't.
That's division. That is easy math.
I don't have it.
And then direction is left. We talked about that earlier. Okay, do y'all think y'all can handle F equals MA?
Yeah.
Yeah? Okay, we have that triangle to help us out. What I don't want you to miss is the big picture here is all of this calculation is Newton's second law. Okay? So let me go back and read that to you. It says the unbalanced net force on an object will cause acceleration. Okay? So in all of these free body diagrams, they're unbalanced, right? So that's why we don't have a net force of 0. Okay? So whenever it's unbalanced, we know that it's going to move somewhere. We calculate its acceleration and we find that out. Okay? So all of this is Newton's second law. Yesterday was Newton's first law. Sound good? Okay. Now,